Yeah. So a lot of development has been happened, and also a lot of challenges. If you see now, what is happening to our nature, right? So if you see now, if you want to show birds to your kids, you have to go to forest now. Earlier, when I was a child, and when I come from remote place like Kitturani Chennamma historical place, there I used to find a lot of birds into my village only. Right now, if I go to my village, I never find birds into the village. They have migrated because we are radiating so much frequencies. These are the challenges we need to look as a designer, as an innovator, as an technology. Whenever you are bringing into that, there should be a we should protect our nature. Okay, so there should not be harmful. So today, okay, at one end we are getting a technology, but other end we should know its causes also. So but now that's why today we are talking about low power emissions. Okay, earlier you used to find bigger tower antennas. They are to radiate higher power. Radiating higher power and frequencies are not good to the nature. Okay, so modulation and need of modulation, one has to design an efficient algorithms, and the technology has to be such a way that it has to radiate the low power, so that you should, and frequencies, uh, that should not be a harmful to the human being. Okay, so these are the challenges to, so that a lot of development has been happened in EM waves from Maxwell. He has proved that electromagnetic waves travel with the speed of light. Okay, today we are talking about different antennas and different modulation techniques and challenges in analog communication, what we see with Bharti and all. Okay, so that how do you propagate the signal in directions, whether to propagate in all direction, whether to one directions, what should be the height of the antenna, and what should be the area of coverage, so what should be the power and all. So today we are living within a digital world. We are talking about digital communications and challenges in digital communication. How do you what should be the bandwidth? Now you need to accommodate, you need to give a number of services or more. I need to accommodate voice, I need to accommodate image, I need to have a teleconference, so that I need a super highways. Okay, today we are talking about super highways. Means what? Like we have seen our super highways in NH4. So we move with a very hassle free, right? So there is no stress free driving, no accidents, optimized fuel efficiency, right? So more economy, of course, right? Similarly, in communication also required superhighways. Today we are talking about optical fiber communications. We are talking about Wi-Fi, light fidelity, light transmissions. Immense data can be transferred, transmit. Today we are enjoying that world. So I think in this pandemic situation, your this digital communication, digital vada, digital era, and also digital India, this moment by the government initiatives, that has helped a lot. But for that requires a lot of infrastructure, right? So that India has taken a lot of India has taken a lot of initiatives into these directions. Now today 5G trials are going on. Okay, but interoperability is also one of the key issues and the challenges in case of communication. Means what? Whenever I'm getting a one technology, there should be a interoperability with an previous technology. 4G user also, whatever 2G, even though I'm getting in 4G technology, 2G user, 3G users should get connected with that kind of networks. Okay, so more and more number of users are we want to serve more, and need more and more services. These are the key challenges. So there is something called a channel capacity. Capacity means there are 500 users. I need to maintain those 500 users into the cell capacity. As and when again there could be another 500 user added into that cell. Okay, suppose say wherein I live into a Pimpri Chinchwad, where at a time 5,000 users are communicating, but over and more or down the line, when I go on after 3-4 years, another 5,000 users get added to that. In that case, then how do you optimize this? Okay, these are the challenges. So that is a beautiful theorem called a channel capacity theorem. Shannon Hartley law. Shannon has contributed, name of the scientist. He has contributed a lot. So the lot of theorems he has brought into the communication domain. So some of the things I'll talk about that in my slides. We talk about source code, tunnel code. So I'll be not going to the depth of this. So today we are talking about wireless communications. Okay. So in that we call it as a cellular communication, where we can enjoy the mobility. User can move from one point to other point. Okay. But of course we are radiating power. Okay. That power need to be minimized very smartly. Whenever user is idle, need not to send the power. This is what I'm saying. Okay. Antenna should not send the power when there are no users. Okay. So that we can save the power also, and also you can protect the nature. Whenever there is an voice activity, send that time only. So we require a smart. Whenever user is moving, then power, that antenna also should move in that direction, so that user get a good voice connectivity, and uh, at base station and mobile station can track. So today we are talking about cellular capacity in the form of hexagonal, right? Whenever user is moving from one point to other point, it is a hexagonal structure. So base station is a fix, mobile station is a movable. This is MS, this is a BS. BS means a base station, MS means a user mobile station. User are free to move from one cell to other cell. Okay, so he moved from here to here. Okay, whenever user is moving from one cell to other cell, these BS and BS should get coordinate each other. Okay, so and there could be a many BS like this, and these many BS are connected to a what? MS. Okay, there is some master station controller. Okay, so maybe it will be at some place. Okay, but whenever a user is moving from one to one, there should be some intelligent systems which should inform to this, hey, this is my user. Okay, take care of here. Okay, sometimes you get your call get dropped whenever you are moving with a very high speed. These are the key challenges. And today, a drop of the call is you might have experienced in your home, or you have to come near to the vicinity. Okay, that is because power in the transmission. So these are the challenges. How do you do it? And when there is a huge data, and how do you do it? And a large number of users to accommodate serve. These are the key challenges. So these are the different technologies. What we have seen it from over the period of 4, 5, 6 decades. Analog communication, information in the form of change in the amplitude. When we talk about frequency, information will be in the form of frequency. When we call phase information, it will be in the form of phase. Okay, we call the phase modulations. When it's analog pulse communication, rather than sending continuous, send it a discrete. Today we are talking about these are the phase informations. This is my information will be in the form of phase. Okay, so we send it in that way. So I'll be not talking on this more. These are the key challenges, how we can overcome it. As signal goes on increases, error goes on decreases. These are the key challenges. But signal we cannot increase more and more. We should have a good trade-off between your signal power to achieve the bit error rate. So bit error rate is a major key challenges. Minimum the error, better the signal quality SNR. Okay, but if I want to increase better quality of SNR, so that where do we do it? Whether I have to do it at a mobile station, I have to do it at a base station. These are the key challenges. So in mobile station, power is limited, whereas base station, I can have a better power. So of course, the power has to change in a both way, right? So we need to take care of such things. So I was talking about Shannon. He is a great scientist. He has formulated that better the SNR. It's a logarithmic. Those who are from mathematical background, we can understand. Better the quality, better the factor of SNR. Okay, so I can increase this. If SNR is going to drop, if this is going to drop, this is going to drop for a fixed channel. That's why today we are talking about, I think most of you might have heard 2G spectrum case scandal. Audience? Can you hear me?
Hello. Yes, sir.
Yeah. 2G spectrum scandal, you might have heard, right? Yeah. So that is all about, spectrum. Everyone want a spectrum. Okay. Everyone want a good spectrum, right? So, so this spectrum talks about what I want. A good spectrum means I have a good, super highways. I was talking about superhighways, right? Digital communications are nothing but a superhighways. So we want better this, right? So that everyone want to enjoy the revenue, right? So there, I'm talking in a lemon way, right? So if I want a good spectrum, I have to pay good amount to the government. There are different auctions are going to happen. So we have to buy the spectrum, right? We have to buy the spectrum so that I am buying my channel. I am buying my channel so that I want to provide a good services and I want to have a good channel capacity. I want to increase my subscribers, right? I need a good spectrum. So that spectrum we have to buy it from the government. We call it TRAIA, Telecom Regulatory Authority of India, and
it's like reserving your highway channel or something.
Right. Today we are talking about 4G and 5G spectrums, right?
Correct.
So this spectrum talks about, I am working on that couple of my work I have done on spectrum, right? Today we do audit. We do audit like energy audit. I think there is no audit in spectrum. I have proposed some of the algorithms so that, this is used, I'm using it effectively, whether I am not using it effectively. Use that allocated spectrum effectively, right? So that is what it is suggested by, channel capacity by beautiful theorem Channan. It's way back, way back a century. I mean, I say that way back 10 decades ago, these kind of algorithms have been suggested. Can you imagine? Still, we are on the same ground. We are using it, right? So these are the key challenges. Are what attenuations and noise is a key challenges one has to look for in the technology, developing the technology. How AI is going to help into that? AI is going to help in the sense it is going to intelligently it sense. It predicts. Suppose say I am moving. AI algorithms will ask you, hey, what are your journey plans? I may feed it to that. Depending on that, inputs, and it informs to the nearby base stations. Hey, this is a plan of this. Can you take care of it? He may be moving. He may be entering into your zone. Okay, so these kind of algorithms, we call a supervised algorithm and label data algorithm means what? It takes an input and it predicts from that, and accordingly, optimize the channel capacity, right? So these are some of the challenges, and these are the hotcakes in today technology. In RF communications, we are talking about co-division multiplexes, orthogonal frequency multiplexes. Today we are talking about MIMOs, multiple input, multiple output, simple input, simple output. Today we are talking about these kind of technology, Li-Fi, light fidelity, and long-term edge evolutions, 5G. And I have worked on these technologies. Okay, these are all technologies I have worked from last 2 decades. My journey started from CDMA to today. We have proposed NOMA, non-orthogonal multiplexes. So I worked with Professor Bahubali, where he was my mentor. I spent around about 6 to 7 years. Now my algorithms are talking about non-orthogonal multiplexes. Means what? There should not be interference, so that more the interference. If I'm saying something, if someone is saying something, signals are going to mix each other. Then how do you separate these two signals? These are the key challenges. Okay, AI is going to help into this. So RF communications, RF with AI is going to help a lot. A lot of work is happening into this. How do you mix? So if I say a signal, this is a very RF is pretty important. I think about the defense, okay, where their defense system is using the RF signals for communicating their maybe they are using aircraft, they are using some kind of missiles, right? If there is an interference, can you think of if you have set the target, it is going to hit the target? Definitely not. Okay, so RF is a key. RF challenges were required a lot of intelligence, right? So these all electronic electromechanical system, I'll say rather, this requires a lot of intelligence, and RF required a lot of intelligence. That is a lot of, this is a hard cake now for researcher, one can take it. So that how do you avoid the mixing of signals? Okay, how do you bring the intelligence into that? How do you separate the mixing of signals? If the signals are going to mix each other, maybe two helicopters are going to collide each other in the space. We won't come to know. Can you imagine? Okay, so that you should these are the key challenging technologies wherein a lot of intelligence is required. I hope I have enlightened some of the challenges as an a takeaway for participants. One can take this is a hot cake now. RF AI, use of AI in RF communications. So I'm talking about for journalism domain, how AI and data science will help into journalism. So today we are talking about what is authentication of information or news which it has been taken by someone as a journalist. There are journalist algorithms where there are self robot which are going to create, summarize your news. These algorithms, robots, what we are calling robot in journalisms, today those are going to summarize the news, like with the benefit of what, its speed will be high, cost will. So I was talking about in journalism. Since there will be a mixture of audience, I wanted to make it interactive, so that today robots are going to give you a correct informations, authenticated informations. So a lot of work is going in journalism, artificial intelligence, data science. Okay, authentication of the data. And today if I am talking in one language, there are interpreters. Okay, so it converts into the what language it's required, so that even though journalist will even suppose say our prime minister talking in Hindi, suppose say that there is a journalist from maybe from France, he may not be understanding Hindi, so it that robots converts Hindi to what it is understandable language in French. I think you pretty understand that this example, what I mean to. And it gives authenticated informations, correct informations. Otherwise, our prime minister is saying something, the robot is saying something. So it gives a wrong interpretation, right? So that is authenticity. And also it gives an authorship, who has been done. Okay, so a lot of intelligence will be added into that. A lot of work is having into a civil engineering, construction management, transportations, geotechnology, building information. I think some Dr. Manoj was referring to me ERP solutions. So we have done some kind of work on ERPs like building informations, AI-based road recommendations. I'm working on road recommendations. If I show the terrain, it will show where I need to assign the boards, where I need to have a strip, lane marking, and automatic lane marking, and signages depending on the terrain informations. And also it will tell, okay, I need to have a pedestrian here, this is a lane marking, and there is an signages, the curving signages, driving safety signages, so on. So I'm working on this. Some of my PhD students are working on AI-based recommendations. So construction use this planning, designing, and all. So some kind of ERP dashboard will help project manager to take care of their task and deadline, and how many employees are required, and optimize the resources. Okay, this is called as a project management dashboard. It can be it can be used. Some of the work I have done along with the civil construction companies, wherein we can know if I just change the lane, so I will come to know how many processes are going simultaneously. If I know the process of construction, there are different activities goes on simultaneously. We'll come to know how many labors are required, what is what kind of cost is required, how much materials are required, how many days are required to complete the task. We can plan it accordingly. So transport intelligence, we are talking about today, AI in logistics. We have seen that today how intelligently it has been done. Shipping is done, product shipping is done. I think Amazon and Flipkarts are using this transport intelligence effectively. AI data warehouse data, whenever we are sending user will come to know where are my products. You are realizing now, right? Today, I think thanks to Government of India, some of my students have come up with even startups. Drop is something. Now someone is coming to deliver the products to your home. No, you will find now in next days, next year, next coming years, there won't be any, delivery boy. The completely robot, sorry, drones are coming, and they will be dropping it at your place. Okay.
Yes.
Means these are the innovations, but there are different challenges. I think I have one startup in my university who has registered at Pune, and he's coming his own design drone at indigenously at the universities. So I think Flipkart and Amazon are coming into that now. Car-to-car communications, okay, machine-to-machine communications are going to happen, and these a lot of intelligences are required here. This is a pedestrian. There is another car. Here's a lane. It has to understand basically. Okay, a lot of intelligence is required today. I think Tata Motors and Benz Mercedes, Volkswagen, they are coming into that. Okay, so now today, when we enter into Pune, maybe at Katras, it will tell you a shortest path. Car will tell you, hey, drive in this way, not by via Swargate. Drive into this way. It will tell you the shortest path. Today we are working on quantum computing. This is a hot cake now. Quantum is a hot cake wherein a lot of fast computations are required. It gathers the information from nearby, vehicles. Okay, and it takes a decision. So where I should route. Okay. So GA technology is another area where we need to know the space application, can be used in space application, know the behavior of the system, and where I'll just go on quickly touch up to some of the information. It's a floor planning. If AR, augmented reality and virtual reality is another hot cake technique. So where it gives you a complete, if you show it to the complete information, it will tell you it's a floor planning. It will tell you, hey, this could be the one of the best plan. This kind of things are technology will help you to save them cost also and error also. Okay, so these are the new trends into AI. Okay, so drones, virtual reality, cloud, and 3D printing, so on, robotics. AI in mechanical applications. It could be used in manufacturing identifications, machine vision, vibration analysis, driverless car, so on. So here we have worked on this. We give a solution to the industry, identify the defective products and corrective. It has to done in an intelligent way. Okay, so we provide solutions, intelligent solutions within wherein we can monitor it remotely also. Okay, it segregate the correct and defective one. AI algorithms will help. AI system will help you to do that. So AI is used in banking today. We can do analyze inside of that. So what is my profit this bank is going to achieve? So where I need to invest so that my customers get a more revenue of that. So, and also today, no need in order to some of my applications. So my students have done the projects like we need not to fill up the form. Go on, do it the voice based. Automatically, it will fill the form and verify it, check it, and just submit it. Okay, voice based, form filling of the form. You need not to, even just if you are able to give a reply and your smartphones are going to serve your purpose. Means there is a lot of work is going into this. It requires deep computing. AWS and Azure are doing it. The good practice, what we are practicing it, AI powered multi-track courses, we have our system. So there are 10 different tracks. We have a specialization courses like computer science, engineering and applications, where we have Bachelor of Computer Application, BCA, MCA. MCA, we have 2 tracks. One is cybersecurity, another is AI. Whereas in BTech CAC, we have got a lot of recognitions from Government of India and other recognizing bodies, wherein AI is all courses are powered by a artificial intelligence, data science, cybersecurity, IoT, mobile computing, web computing, transport intelligence, fintech, and then bioinformatics. Like 10 different courses we have. We have all courses are powered by AI. We involve AI as an intelligent technology, right? So our students are doing good, and we have a PhD into interdisciplinary course. So all the schools, like we have bioengineering schools, we have School of Management, School of Journalism, and then School of Design, and then School of Computer. These are the 5 schools which we have. And again, we work cohesively. Our faculty go and teach to the other schools. School of Design faculty come and teach to our students. We have design thinking, design project right from into curriculum. So we something called as a lab in a bag. This helped us to do in the pandemic situation. So students can do their project. Their home itself is a bag, lab. Okay. So small, it's not required to have not more than 2,000, 2,500. So even we have shared these things to the even IITs, NITs. Recently, there was a UGC committee. There were some official directors, UGC panel members. We have shared all the things to them. Even in this pandemic situations, they can use it. Even if some of you can come up, we'll share the things that will help to the student community. Their home itself is a lab. Their study room itself is a lab. Okay, that can be done very possibly. So Idea Lab, we have brought Idea Lab where it achieved the, even though I think Government of India taken a lot of initiative into this. They are giving a fund to this. We have done within a 15 lakh rupees. We have done a beautiful Idea Lab. One can come and see. Okay, we are getting our own autonomous robot, which will now indigenously, like it will now it is walking. Okay, so there is an intelligence we are adding it. We are providing social outreach programs like some of our schools. E-enable, through that, E-enable is in society. Through that, we are giving those who have lost their limbs, hands. Okay, we are giving them prosthetic arms. We are printing it and we are doing it free of cost to them. Okay, those who have, so if you come across, please let us know. We'll reach to them. So our students will go there and explain and how to use, and we print them, we will give them. Okay. So we are having a deep computing facility. A student can log in remotely, they can work it. Okay. So we are having AR and VR into our university, where augmented reality, virtual reality, student use mixed with an AI. So I believe that. So I'll try to wind up myself. Roots of educations are bitter, but fruits are sweeter. It is a continuous ongoing process. Learning has to happen, ongoing. Okay. So I'll stop here. These are my research work which I have done. So if you have some queries, I'll open now topic for a discussion. You can ask some of the work. These are my works which I have done. So these are the work which I have done. So these are some of the results I'll be not discussing. It's available on the internet, and you can find my papers on the Google Scholar in my name. So this was my work. So I was talking about NOMA somewhere. So these are the key findings of my works. I was talking about power. Power should not be more. So I should minimize the power. So I believe on this. So learning by doing, keep on learning, work in team, always motivate the students. So thank you one and all. Now I'm open for a discussion.
Thank you very much, Dr. Bahubali, sir. Excellent presentation. Lots of information covered, and especially correlating to my passion of manufacturing and Industry 4, and my background in electronics engineering. I did from D.Y. Patil in 1989. From
right.
HA.
You are from DY Patil.
I am from DY Patil. I am a great grandson of DY Patil, I would say.
So nice, sir. So please visit our university. I'll introduce to my honorable VC, sir. And it's a just 4-year-old university, but under the mentorship of Dr. Prabhat Ranjan, who has worked with Abdul Kalam, sir. And he's a founder VC. And I got a chance to work with him. And DY Patil Group, Honorable Satesh Patil sir and Banti Patil sir, they have good vision. So we have one university at Talsandi, Agriculture Technological University. This is a university where we are focusing on cutting edge technologies. So it is at Akkudi only. Okay. So we all, I welcome all of you to visit our place and see what we are doing. We can take some of the things, we can reach society in a better way. So I think
absolutely.
Yeah, thank you everyone for listening me patiently. So you can write me a mail. Okay, so I think bahubali.sirgapur@dypiu.ac.in. So I think I have to stop here my presentation.
Yes, you did manage your time management is excellent. We started a bit late and you exactly took the 1 hour slot.
Yeah, thank you very much. Thank you very much. Yeah,
thank you,
sir.
Any questions, comments from any participant, eminent dignitaries for Dr. Bahubali, sir?
Yeah, I think yeah. So if you have, if some of them you are from the institute, from engineering background, even though from maybe you have a schools like 11th and 10th, wherein student want to set up your robotics lab, and maybe you want to set up ID lab, we can help you into that. Okay, so we can share you the our technical details, so you can set up at your institutes. You can serve better to the society.
Maybe you can, if it's possible, you can put your contact information in the chat box. That would be helpful. If
sure,
possible.
sure. Yeah, I'll put it.
Okay. Thank you very much, sir.
Thank you, sir.
Okay.